As you may recall, the Kinect region is the control responsible for the hand cursor behavior and acts as a container for every interactive element that you can manipulate using the hand cursor. Let's have a look at what kind of customization we can achieve via its properties. After that, we will dive deep and change even more stuff, such as the design of the hand pointers. There's only a handful of properties you can change on the Kinect region control itself. The first one is the isCursorVisible property. If the value of this property is false, the hand cursor won't be visible. This doesn't mean that the hand cursor is not there. You can still activate buttons this way, it just seems like you're the invisible man. You can also change some colors of the hand cursor. The first property to do this is called Cursor Pressing Color, and it defines the color of the little circles that fill the cursor when the user pushes her hand forward above a button. For example, in this screenshot, the purple fill color has been replaced with bright green. The next two properties are Cursor Extended Color 1 and Cursor Extended Color 2. These define the color of the hand cursor when the user's hand is extended and the UI element is activated, such as when a button is pressed. The two colors define the gradient field of the hand. For example, if I set the first one to red and the second one to yellow, this is the kind of result I get when I pressed a Kinect circle button. The last set of color properties are the Cursor Gripped Color 1 and 2. Just like the Cursor Extended Color properties, these two define two colors of a gradient that is visible when the user grips, such as when she wants to scroll a Kinect Scroll viewer. Changing these colors to red and blue result in a gripping cursor that looks like this. The last property I can discuss here doesn't have anything to do with the visual representation of the cursor. It is actually a way to override the built-in algorithm that decides which user has control. It is implemented as a very simple callback system. You provide a callback method with a predefined signature to the query primary user tracking callback property of the Kinect region control, and this method will be called for every interaction frame. You just return the tracking ID of the hand pointer that you want to be in control, or 0 if you decide not to have a hand cursor for anyone. The input properties of the method are the proposed tracking ID, a list of the candidate hand pointers, and the timestamp measured in milliseconds. Here is a sample implementation for this callback method, which accepts the proposed user for 1 second and then takes away the control for the next second by returning 0. This is obviously just a silly example. In a real-world scenario, this callback method can be used to have the person closest to the Kinect to be in control, or the tallest one, and so on. The Kinect region control defines one last set of properties. These are attached properties, useful for when you are creating your own Kinect-enabled controls. The isPrimaryHandPointerOver property is analog to the isMouseOver property, and it is set to true when the hand cursor is over your control. The isGripTarget property should be set by your control to indicate that a grip gesture can be performed over it, and should be enabled whenever the hand cursor is over your control. Similarly, you should set the isPressTarget property to true if you want to do a pressable control and enable the press gesture so that it can be performed. Finally, the pressTargetPoint property defines the relative coordinates within the press target, where the press center is. Both coordinates of the point should be between 0 and 1, with 0.5, 0.5, meaning the center of the control. This is all we can do by setting properties on the KinectRegion control. But what if you want to do more? What if you want to change the shape of the hand cursor? We have to go deeper into the world of templates.